Hey everybody, welcome back to another episode. So in the previous episode we set up the Vertex buffer by allocating specific memory for the CPU to write to. We also determined which type of memory would be optimal for the CPU to write to, but just because it's memory that is available for the CPU doesn't mean that it's optimal for the graphics card to read from it. According to the Vulkan tutorial that I've been referencing pretty heavily, Alexander Overvoort's, the most optimal memory for the graphics card to read from will be the memory that has the VK memory property device local bit flag. And this memory isn't usually accessible by the CPU, so we're actually going to need two different buffers. We have our Vertex buffer, and we're also going to need a staging buffer. And the reason we're going to do that is because we're going to make it so that the Vertex buffer is actually in the memory location that's optimal for the graphics card. And then, since that's a type of memory that the CPU can't access, we're going to make the staging buffer for the CPU to write to. And then we do a buffer copy to transfer the data from the staging buffer to the Vertex buffer. So this way both the graphics card and the CPU are utilizing their optimal memory. Now before we get into copying any buffers, to successfully copy a buffer we're going to need to be using a cuefamily that has the VKQ transfer bit flag. And technically the graphics queue that we've already found will have that capability, but I'm going to alter how our engine handles cuefamilies so that it finds a separate cuefamily for transferring if one is available. So before we do anything related to the staging buffer, I'm going to move everything for handling cuefamilies and command pools into their own classes, since we're going to need a separate command pool to submit the transfer commands on. So let's go ahead and get into that. First off, we're going to make a new class specifically for cuefamilies. So add class. Someday it'll load up. There we go. Alright, and we're going to name this class PVQFamily. There we go. Alright, so we're going to go through all our usual stuff. We need to... Oh, come on. It's running a little slow today. Alright, so usual stuff. We need namespaces. So namespace, and I forgot my namespace. There we go. PV engine. I'm just going to copy and paste this, speed things up a little bit. Do one over here. There we go. So now that we have this place to put all of our cuefamily code, we're going to go back over to, where was it? I believe it's just in our engine code, planetVulkan.h, and we're going to grab all of the cuefamily stuff and drag it over there. So we have our cuefamily indices struct. We're just going to cut that. Let's get rid of some of this white space. And we're just going to drop it right at the top here. And actually we don't need any of this. We're not going to be creating instances of the cuefamily class. We're just going to store some of our information here. So we have the cuefamily indices struct, and we're actually going to want two different families here. So we have display family. I'm going to rename that graphics family. I think that'll sound better. And we're going to make a second one for the transfer family. Go, and we need to modify isComplete now because isComplete needs to check both of those indices. So we're going to return graphics family greater than or equal to 0 and transfer family, there we go, greater than or equal to 0. And I'm going to put these in parentheses. You don't have to, I just like to. It keeps things grouped. Alright, so now that can properly store what we need, we also had the fineqfamilies function, which I believe should be... you know what? We should grab it out of the header first, so... There we go. Cuefamily indices, fineqfamilies. So, once again, ripping that out. And jump back over here. Oh, there we go. And we're just going to put that down at the bottom. And we are going to need to pass in some things that we weren't passing in before. Oh, you know what? First, we should probably include Vulkan, because this isn't going to do anything without it. Hash include Vulkan, Vulkan.h. Great, so now it's recognizing the VK physical device. Now, since this is now a separate class, we're actually going to need to make these pointers so that we can pass in a reference to the physical device, and I'm going to make it constant just so it doesn't modify anything by accident. Alright, now let's go ahead and go get all of the code for this. So we're going to, where did it go? Planet Vulkan CPP, find cuefamilies. Here we go. So we just grab this whole thing. Once again, just rip it out of there. Great. Go to cuefamily CPP. Once again, we don't need these, and we're just going to drop it right there. And now we've got a few things we need to fix up here real quick. To start with, we are not in the Planet Vulkan class anymore, so we can go ahead and remove that scope. Alright, it's not called display family anymore, it's graphics family. There we go. And we are going to need the surface. So since we're not in planetvulkan.cpp anymore, we don't have a direct reference to that. So we're going to go ahead and make a const vk surface. I have papers here. There we go. khr, and that's pointer, and we'll just call it surface, so we don't need to change any names. Let's see how that worked out over here. It's still having something else. Oh, we didn't include vector yet. Go ahead and just drop that right here. There we go, that fixed up a lot. Oh, of course. That's why it's still not recognizing these. The definition and the declaration need to match. There we go. And for all the situation, any spot here where it says device, we're going to need to change that to a dereferenced pointer, because it needs to get the object at that pointer. There we go. That looks a lot better. Now let's modify this so that it can actually find a transfer family as well. So we have this right here. This is checking for a graphics family. We're going to copy and paste that. And we're looking for a different Q flag this time. We're going to say, is that it? Wow, okay, there's actually been a pretty major issue with my code. Some of you may have caught this a long time ago, but it looks like right here I have cuefamily Q flags. So that is the bitwise flags that have been set for the cuefamily. And then over here, this is the graphics bit that I'm checking against the Q flags. And for some reason, I'm using a double AND. You need a bitwise AND, because you're combining these together and you're checking whether it's you're doing a bitwise AND, and then you're checking whether it's 0 or non-zero. And if it's non-zero, then it means that that bit is present. So this was not working correctly, but now it is, so great. Okay, we're going to go ahead and fix that. So down here, this is going to be the transfer family. Alright, and we don't, well, you know, I'm going to leave that there for a second, but here's what we ultimately want to do. We want to test whether, come on. We want to test whether the graphics bit is not set and the transfer bit is set. Because the thing is, the VKQ graphics bit can handle transferring, but if we're just going to use the VKQ graphics bit for transferring, then we don't really need a separate Q family for transferring. We just use the same one. So what we're going to do here is we're going to use VKQ, and it is the transfer bit. So we're checking whether transfer bit is true, and we're also going to check if not VKQ graphics bit. So that should find something that has the transfer bit and does not have the graphics bit if it's available. And if it does, then it'll assign it to I right here. And then the last thing we want to do is before we return, we want to make sure that we actually have a transfer family. So just right down here, before we return indices, we're just going to do a test if it should be indices dot graphics family is greater than or equal to 0, and indices transfer family equals -1. So if that's the case, then that means that we found a graphics family and we did not find a transfer family, and we really don't want that to happen. So if that is the case, then we need to make sure that we're using the same graphics family as our transfer family. We don't want to do that, but if it's the only thing available, then we need to be able to roll back to that. So then we're just going to do indices transfer family equals indices graphics family. There we go. So if it turns out we don't have a dedicated transfer family, then we'll just use the graphics family. And that should do the trick. Alright, so we've got our cuefamily stuff set up. Let's move on to moving over the command pool code. So we're going to make another new class. Add class. Alright, we're going to name this one PV command pool. Alright, same stuff as before. We want to go grab our namespace just so everything's all contained together. Helps separate our engine code from our game code. There we go. Alright, and now we can start filling all this out. So first off, we are going to need a private variable. Be better if I could spell, but so it goes. And, oh, right, we need to include Vulkan again. There we go. So we need a VK command pool. And we're just going to call that command pool. Alright, now since it's private, because it's contained in this command pool class now, we need a getter for it so that other classes can access it. So we're just going to do VK command pool pointer get command pool. And that's just going to return command pool. Sorry, a reference to command pool. Like so. Alright, so now we also need a create function and a cleanup function for the command pool. Now, I'm going to do this a little strangely. I'm going to make the create function public, and I'm going to make the cleanup function public, and the create function private. Because I want to be able to call the cleanup function directly, but I figure the create function we can just call from inside the constructor, so we don't have to construct a new command pool and then also call create on it. It can just do it all at once. So I don't know if that's really the best way of going about it, but, you know, it'll work. Maybe later on I'll change it if it's not the most optimal way of doing this. Alright, so we have cleanup and we have create command pool right here. And we're just going to drag over some of the stuff from the Planet Vulkan class again. So we have create command pool right here. We're just going to go to the definition of that, and we're going to grab everything, copy it, and go over here to PV command pool and paste it in. And let's go ahead and grab the stuff for the cleanup function as well. We can delete this because there's no need to have that create command pool anymore. And let's go ahead and get it out of planetvulkan.h as well. Yeah, this is it right here. Alright, so none of that will be necessary. And let's see where we do cleanup. VK destroy command pool is the one we're going to want. So we can just I'm just going to copy that for now, because we still are going to need to call cleanup here. So we'll come back to that a little bit later. Alright, and then over here, we're just going to do void cleanup. Oh, there we go. And this needs to be VK destroy command pool. Give it the proper scope, because both of these have incorrect scopes. There we go. And now there's lots of stuff we need to fix up here, so that should be lowercase. And we can also use this to decide what kind of arguments we're going to need to these functions. Let's take a look at the cleanup function first. We are going to need a logical device. So for that, we're just going to pass in a constant VK device pointer, which is our logical device. There we go. And since this is now a pointer, we are going to want to dereference that pointer right there. And we're going to copy all this and paste it into the header. So that should be everything we need for the cleanup function. The create function is going to be a little bit messier. So we are going to need a logical device again, so let's go ahead and paste that same VK device in there. And we'll dereference this. Let's see what else. We also want... we're going to need a cuefamily index right here. And it turns out we don't need to do a find cuefamilies. In fact, we want to use the same ones that we chose previously. So I'm just going to have our Planet Vulkan engine pass in the Q index that was chosen. So I'm just going to make a uint32t, which is the Q family index. And this, since we're going to have multiple command pools, we can pass in different indices here based on what's found in the engine. And I also want the ability to pass in flags. We are going to need some flags when we start making the transfer command pool. So we're just going to do VK command pool create flags. And that'll be flags, just like so. Alright, so we're just going to grab all that. Oop. Here we go. I'm having trouble copying this. There we go. And we're just going to drop that right over here and create command pool. Wonderful. Now we only need to make a few small changes of this. We have the cuefamily index, and we don't need to actually grab the cuefamily indices from fineqfamily anymore. We can just get rid of that altogether. And for the index, we're just going to pass in the cuefamily index that was passed in as an argument. And also, we never actually set the flags in our previous create command pool because we weren't creating a transfer command pool. So we're going to do pool info, and there is a flags section to that struct. And we're just going to set that to flags. There we go. Ooh, and you know what? I did not include IOStream. There we go. That should fix the cout and the runtime error there. Wonderful. Okay, and actually one other thing we should do, we don't necessarily need to pass in flags. There's a possibility that whatever we have doesn't have any flags, so I'm just going to do equals 0 right here, give it a default argument. And then over here, I'm just going to put a comment so it's clear that that has a default argument. So you don't have to pass flags into this. You can leave it empty and it'll just pass in 0. So that should do everything we need. Alright, and the last thing we need to do here, since I did say that we were going to call the create function in the constructor, we're just going to grab this, drop it here, and we're now going to have to pass in all of these same arguments into the constructor. So we just grab it again, right there, and we're just going to get rid of all these types. That should do the trick there. Alright, and then of course we're going to have to copy this over into the header as well. And once again I'm going to give this one a default argument. It's kind of redundant to have it both here and here, but I don't believe it'll hurt anything. If it does, I can come back and change it. Alright. So I think that's everything we need for our command pool. Before we get too much further ahead, we are going to need to go back into our previous code and make sure that everything still functions, because we just broke a lot of stuff by moving all that code out of Planet Vulkan, the Planet Vulkan class. So let's hop back over here, and let's see what we need to take care of here. We're going to need to include the headers for both of those classes we just created. So include, we're going to have PV cuefamily, and we're also going to include its PV command pool. Alright, so now we can at least access those. Alright, now we can go ahead and remove the declaration for fineqfamilies, which we may have already done. Yeah, it looks like. Let's just be 100% sure. Yep, it's gone. So fineqfamilies, create command pool. Looks like we got rid of that too. Guess I'm ahead of myself today. And the old command pool handle that we had, so there it is, VK command pool right here. That is no longer necessary. Alright. And we're going to replace that handle with two PV command pool pointers. So it's going to be PV command pool pointer, and we'll call this a graphics command pool, not poll, pool. And another one, so PV command pool pointer, this will be transfer command pool. There we go. Alright, so let's just hop back over to the CPP, and before we do anything, let's go ahead and add delete calls for these, because it is easy to forget to do that. So we're going to do a delete graphics command pool, and delete transfer command pool, just to make sure that that memory is freed up when we're all done. So now we need to create new command pools. So instead of calling this create command pool function that we had before, let's get rid of that. And we're just going to call new on both of the pointers that we created. So we're going to do graphics command pool equals new PV command pool, and we're also going to do one of those for the transfer pool. I do have issues spelling. Oh well. Alright, and now we just need to pass in the proper arguments, so it needs, let me check here again. Yeah, it's not going to work with me, I guess. So we need the logical device, the cuefamily index, and any flags. So, logical device. And we don't have a cuefamily index yet, so we'll come right back to that. And I don't believe graphics is going to need a flag either, so actually, we'll just leave it there. Copy this down into transfer command pool. Once again, we'll leave the index empty, and it is going to need a flag. It is the VK command pool create, there it is, create transient bit. And all that this flag is telling you is that ultimately any of the command buffers from this command pool will be short-lived. They won't last for very long, because we're just going to use it for a transfer command and then we're done with it. So this just helps it handle the memory a little bit better. So now we actually need those cuefamily indices for these two command pools. So what we're going to do is we're going to make another call to the fineqfamilies, but we're going to do it here instead. That way everything's handled here and we can pass those indices in. So just do indices equals fineqfamilies, and we just need to pass in the proper arguments there, which should be the physical device and the surface. There we go. And so that should fill out the indices that we need, and if that's the case, we can just pass in indices dot graphics family, indices transfer family, just like that. Right, now there are a few more things we need to take care of. In cleanup swap chain here, we passed in a command pool, and that command pool doesn't exist anymore. So what we actually want is we want the graphics command pool specifically. There we go, graphics command pool. And we need to actually call get command pool to get the command pool object itself and not just the PV command pool object. And we also need to dereference it so that we get the actual object and not the actual command pool and not a pointer to it. Alright. And then up here we're going to need to fix cleanup Vulkan a little bit. We don't want to call vk destroy command pool anymore. We actually want to call cleanup on both of the command pools. So we're going to do graphics command graphics command pool cleanup and transfer command pool cleanup. And those need the logical device, I believe. Let's see. You gonna give me my... Yes, they do need a logical device. So. And we'll just grab that one as well. And that should do everything we need. Now, we still have a few more errors in here, so let's see what's causing those. Yes, okay, so any of the fineqfamilies, we need to pass in the device and the surface, and we don't have that. So they also need to be references and not the object itself anymore. So we pass in the device and the surface here. Let's check the next one. Same thing again. It's going to be a lot of these. Physical device, surface, and we need to change this to graphics family. Down here, this is going to be another graphics family. And looks like we have one more. Create command buffers. And actually, this one we're going to leave alone for now, because we're going to be messing around with the buffers in just a second. So just ignore that one error for now, and well, it should be resolved shortly. Let's actually move on to creating our staging buffer. So we already made the vertex buffer last time. We're going to need to make more buffers, so it would honestly make more sense if we just created a class for buffers and then had the vertex buffer inherit from it. So we're going to make a new class. Alright, this is going to be PV buffer. There we go. Let's grab our namespaces again. And over here. There we are. Okay, go ahead and I'm going to pin these so we don't lose them. And let's bring our vertex buffer over here so it stays nearby as well. And where's its CPP? Here we go. Great. So we're going to copy some of the PV vertex buffer into PV buffer. And you know what, actually let's just do this right now. We're going to go to the vertex buffer and we're going to make it inherit from the buffer class. So we're just going to put a colon there, and we're just going to put public PV buffer, just like that. And we do want this to include PV buffer, like so. And we can take all of this right here, because our buffers are going to need that. And we're just going to store that as an include in PV buffer. So let's start making some functions for this. We're going to add a protected section. And the whole point of that is so we can write some functions that are internal functions to anything that inherits from PV buffer. We're going to need a create buffer. We're going to need a cleanup buffer. And we are going to need that find memory type function that we were using before. I believe that's still in planetvulkan.h. Let me see. Find memory? Might only be in the CPP. I'm starting to lose track of where everything is in here. Okay, I'm going to stop. And we're also going to need the find memory type function, which we have over here in Vertex buffer. So we're just going to grab that out of there, grab the header, drop it in here, and since that one's nice and easy to move over, we're just going to go rip the whole thing out and drop it into the CPP. There we go. Alright, and we do need to change the scope of that. We're just going to grab PV buffer and just paste it. So that should work. Alright, now let's go ahead and start filling out these functions. So we're just going to grab create and clean up buffer, drop them right here. Let's give those a body and scope. And now we're going to borrow a lot of the code from the Vertex buffer that we already wrote. So we're going to go to its create buffer. And we're going to rip out everything down to about, should be right about, oh god, here we go, right at VK bind buffer memory. So we're just going to cut there. We're going to go over to PV buffer, and then drop it right into create buffer. Let's go ahead and take care of cleanup buffer too. So over here in PV Vertex, once again, we're just going to grab everything out of cleanup, go back to PV buffer, and just drop it into cleanup buffer. Nice and simple. And then we need the arguments. So we have the Vertex buffer and the Vertex buffer memory. So why don't we actually make something for these to reference? We're going to go back to the header, and we're just going to add a VK, oh sorry, not VK device, VK buffer. And that'll be buffer, and we'll add a VK device memory, buffer memory. So now any buffer we make will have these variables, and we can also make a getter for the buffer. So let's do a VK buffer pointer get buffer, and that'll just return the buffer, or sorry, a reference to the buffer. Now that we have that, we can go back to the CPP. We can totally remove the... Well, actually, no, we can't. I'm sorry. We can replace Vertex buffer with our buffer. We can replace Vertex buffer memory with buffer memory. And we do still need to pass in that logical device. So let's see if we had that over here. In cleanup, we just get constant VK device logical device. Drop it here. Put it in the header as well. And cleanup buffer should be ready to go now. Let's move on to the create function. So we're going to need the logical device like always. So const vk device logical device. We're also going to need the physical device. So go. We're going to need the surface. The reason we're getting the physical device and the surface is because we're actually going to have to call the fineqfamilies again. You'll see why in a moment. God, I can't spell. Surface. There we go. Let's see what else. We're going to need a size for the buffer. So vk device size. And that'll get passed in. We're going to need usage flags, so it's vk buffer usage flags. Property flags, so vk memory property flags. And I believe that's everything. That should do the trick. Oop, misspelled this. And let's drop these down into a couple lines so we can actually read it. Let's do that. Much better. VK surface KHR. Always forget that one. Much better. Alright, so we're going to take all these arguments, move those over to the header file. Great. And now we can go through and start filling this out. So for vk create buffer, this is just going to be the buffer that we have. We'll come back to the size in a second. This should be the buffer as well. This should be the buffer memory. Once again, buffer memory. Alright, so that takes care of just about everything except this size right here. That we can just replace with the size that we passed in, which is the whole reason we passed it in. We also want to replace the usage because we don't necessarily know this is going to be a vertex buffer. So usage is going to be usage. Alright. And then for the sharing mode, we're actually going to want to change this to vk sharing mode concurrent because we're going to have multiple buffers now. And sharing mode concurrent is going to tell us that the resources should be shared amongst all of the different cuefamilies that we have. And we're actually going to need to pass in those cuefamilies. So what we're going to do is right underneath this, there's a couple of buffer info. There's a couple pieces of data within the vk buffer create info that we didn't mess with before. So there's a buffer info p cuefamily indices. And there's also a buffer info cuefamily index count. So we need to fill these out with all of the cuefamilies that we're using and then how many of them, so that way it knows what to share between. We know that there's going to be 2. I'm just going to put in 2 there. And we need an array of the indices to pass in here, so we're actually going to need to retrieve those. And this is why I passed in the physical device and the surface. We're just going to do a cuefamily index. Indices, ooh, you know what? I need to include that. It's going to be PV cuefamily. Work. There we go. Cuefamily indices. And it's going to be indices equals find cuefamilies. And we pass in the physical device and surface. So that will populate this indices thing. We can use it again. But like I said, we need an array. And this isn't giving us an array. This is giving us a struct. So we're going to make a uint32t indices array. And this is going to equal indices graphics family and indices transfer family. And it's not recognizing these because these aren't uint32t's, so we're going to cast those. Just do a static cast uint32t, and we'll just wrap this up in that. And why don't we just, oh, uint32t. Just drop one of those here as well. And this is graphics, not graphic. There we go. So now we have an array, and we can just pass that in indices array right here. Doesn't seem happy with that. Ah, I forgot to put a semicolon. That's a terrible mistake. Don't do that. Alright, and we still haven't dealt with the properties yet, which it appears I forgot to give a name, so there we go. VK memory property flags properties. And down here we do find memory type, and I'm passing in very specific properties. But we might not want these, depending on the buffer that we're making, so we're going to change that. Also, I should probably change all these errors just to say failed to create buffer, because this would now happen on any buffer being created. It only takes a moment to fix, so let's do that. There we go, much better. All right, let's handle these properties. What we do is we take the ones we had before, and we just replace that with properties. Quick, simple fix. So now that we have all this set up, we can take care of it by calling create buffer inside the vertex buffer, just like this. And it wants us to pass in the logical device, which we already have, the physical device. It doesn't look like we have a surface yet, so we should probably do something about that. So we're just going to add that here. All right, and we'll pass that in a minute. Okay, surface. What else do we need? The size, the usage, and the flags. Actually, you know what? I think when we added the name properties here, we forgot to put it in the header. I forgot to put it in the header, so there we go. Much better. Okay, getting back to here. So we need the surface, we need the usage, size, usage, and properties. So we're going to need to calculate the size, so we're just going to do it right here. We're going to do vk device size. There we go. Call it buffer size, and it's going to equal the size of, and this is going to be vertices 0 times vertices dot size. And if you remember, those are right here. It's this vector of vertices that we made, and it's taking the size of a single element times the number of elements, and that's giving us the size that we want. So now we can pass in size. For the usage, we want vk buffer usage vertex buffer. Yeah, there it is. Oh, I said size here. This should have been buffer size. There we go. Alright, so there's our usage. And now we just need the properties, and these are going to be the same ones that we deleted when we copied it over to PV buffer. It's vk memory property host visible bit, and we're going to do a bitwise OR with vk memory property host coherent bit, and I'm going to drop that onto another line because you can't read it. Alright, and then down here in vk map memory, we can just change that to our new buffer size. And the same is true right here. For the mem copy, we're just going to use buffer size as well. And I think we have everything being passed in properly here, so I don't think we need that comma there. And why don't we just take everything here, copy it, and replace it in the create function right here. So now everything should match up properly. And I don't think we're going to need this vertex buffer or vertex buffer memory anymore, because that's now being stored in PV buffer. And we also shouldn't need this getter function anymore, because we now have that in PV buffer as well. So I think everything should be good here. Oh, right. This needs this create function here needs to be buffer memory, not vertex buffer memory. Same for here. That was weird. Okay. That all looks good to me. Alright. let's make sure everything is okay. So we still haven't made our staging buffer. This has all just been copying things over and making sure everything is still working properly. So right here we need to pass in the surface as well. Great. Down here. You know what? Actually, I was silly about this earlier. We could have just passed in the graphics command pool. Get command pool. Like that. Dereference it. We didn't need to do anything different to make that work. And then right here, get vertex buffer, we're just going to replace with get buffer. And in theory, everything should still be running, so we're going to test it out real quick and see if it still works. You know, before we do anything, we should probably take this cleanup function, have that call cleanup buffer, just so we can properly get rid of the vertex buffer. Just get the logical device, pass that in. Okay, that looks much better. Alright, let's give this a run and see if it works. If not, we'll at least know where our errors are. Oh, that already looks bad. Alright, what is the problem? There it is. Turns out I put the parentheses in the wrong spot. This needs one here, because we're only getting the size of a single vertex. And then we also need parentheses here after size. So that should run a little bit better. Let's try it now. That looks pretty good to me. Alright, so everything's still loading up properly. We still have the triangle. It still shows everything being created. So now we can actually move on to finally creating the staging buffer after all of that refactoring. So what we're going to do here, we're going to modify create buffer so that it actually creates a temporary buffer to store the data. And then we're going to make a second call to create buffer for after we map the memory. That's going to be our actual vertex buffer. So we're going to make a local VK buffer called staging buffer. Just do that right underneath where we get the size. This is staging buffer. And we need VK device memory for it again. This will be staging buffer memory. Great. And so those are going to get passed into create buffer. We're just going to grab those. And these should go... Ooh, you know what? Probably should have made it so create buffer could actually pass in stuff. That was not the best move. Here, you know what? Let's go ahead and change this then. So we're going to go to create buffer, and we're going to have it pass in references to a VK buffer and a VK device memory. There we go. Drop these down onto another line again. And let's go back to create buffer. Here, I'll copy these. Create buffer. That didn't work. Weird. Whatever, we'll just go here. Drop it in there. Next line. Great. And then we're going to have these be passed in. Come to think of it, if we're passing it in, maybe it's better to have everything stored locally. So I'm going to pull these back out of PV buffer. We're just kind of going back the other way now, but that's okay. And we'll drop those back into the vertex buffer. And I'm going to rename them back to what they were. There we go. So now we can pass those in by reference. And let's go back over here. So we are going to need to move the getter back into vertex buffer as well. And somewhere down the line I may end up changing this all back around again, who knows. But at least this will work. Okay, so that looks happy again. Alright. This should be okay since... Oh, I'm going to need to pass in references down here for the cleanup as well. There we go. Alright, so the bad news is now we have to pass everything in by reference, but the good news is we don't need to change any names because it's using the same names as before, and now everything should be handled properly. So let's get back over here. And at the end of create buffer here, since we've made these temporary staging buffers, we're going to pass in staging buffer and staging buffer memory. So now this will be creating staging buffers. We also want to change some of the parameters that are being passed in. So the vertex usage, the buffer usage vertex buffer bit, we're going to change that to vk buffer usage transfer source bit. So this flag is indicating that the buffer can be used as a source in a memory transfer operation. And we're going to need a destination buffer to receive the transfer. This is going to be our actual vertex buffer. So we're going to just copy create buffer. And right after unmap memory, we're going to drop that in. And this will be the destination bit. And we're going to want to bitwise OR that with what we had before, the vk buffer usage vertex buffer bit. So now we're indicating this is a vertex buffer and it is the destination of a transfer operation. Now if you remember, the whole point of doing this is also to use the ideal memory for the graphics card. So we're going to delete the visible bit and coherent bit, and we're going to replace that with what I said before, which is the vk memory property device local bit. So that should be the optimal memory for the graphics card to use. And the last thing is we need to change all of these to the staging buffer memory. And down here, since this is the actual vertex buffer, those are what's going to use the vertex buffer and vertex buffer memory. There we go. So now we have our source and destination buffers, and everything's set up for us to copy from one to the other, but we don't actually have any way of doing that yet, so we actually need to make a copy buffer function. So we're going to hop back over to the PV buffer, and we're going to make a copy buffer function. So just right underneath find memory type, we're just going to do void copy buffer. And this is going to need quite a few things. We're going to need a VK device. Oh, should have put that in the parentheses. And which is, of course, our logical device. Then we're going to need a command pool. It's going to be our transfer command pool, but I'm just going to make it any generic command pool so that if we needed to use this again later on, we could. Then we need the source and destination buffer, so and we need the device size. And we need the transfer queue, which once again, I'm going to make generic. It is going to be our... ultimately, you just need a queue, and for us, it's going to be the transfer queue, but I'm just going to name it queue. Okay, that's everything we need there. I'm going to copy that, drop it here, and now we need to fill this out. So let's get the scope real quick. Okay. So if you remember when we did drawing commands, they had to be submitted on a command buffer. So memory transfer operations require this as well, but we're going to make a temporary command buffer to handle it. So to create it, we're going to call vk allocate command buffers, and we pass in the dereferenced logical device. We need an allocation info, which we haven't filled out yet, and we're also going to need a reference to the command buffer that we're creating, which we'll just declare right here. So vk command buffer, command buffer. Alright, now let's fill out that allocation info real quick. So we're going to do a vk command buffer allocate info. Let's call it buffer info. Since we have that, we can just drop it right in here. So a reference to buffer info. So at least that's all filled out now. And now we need to fill out each piece of data. So the buffer info dot s type. It's going to equal vk structure type command buffer allocate info. It has something for level, which is going to be vk command having trouble typing today. Buffer level primary. Then we have buffer info command pool, and that's going to be the command pool that we passed in. And then buffer info command buffer count, which equals 1. I think I need to dereference that as well. There we go. Alright, so we've got all that. That should take care of everything. Then we need to start the command buffer. So to start the command buffer, we're going to call vk begin command buffer, and we just need to pass in the command buffer that we created. Oh, that's why. There we go. Command buffer. And a begin info, which I'm going to fill out in just a second, but I'll go ahead and name it here just so we're already a step ahead. So it's going to go right here. It's a vk command buffer begin info. Call it begin info. And the data we need to fill out here is there's an S type, which is going to be vk structure type command buffer begin info. And we also need to fill out a flag. And the flag we're using is vk command buffer usage 1 time submit bit. So all that flag is doing is it's saying that we only plan on using this for a single copy, and then we're done with the command buffer. Now we need to actually submit the command to copy. So this is going to be a vk cmd copy buffer, and we're going to pass in the command buffer, the source buffer, the destination buffer. Then we need the region count, which is 1. And for the reference to the regions, we're going to pass in a copy region, which is something that, again, we need to fill out ahead of time. So right above it, we're going to declare a vk buffer copy, call it the copy region. And now we need to fill out data for this one. So the copy region dot size is going to equal the size that we passed in. Actually, I believe that's the only bit of data we need to fill out. So that should do the trick there. Then once we've submitted that command, we can end the command buffer. So we're just going to call vk end command buffer, and of course pass in the buffer that we're ending. And then finally we submit to the transfer queue, whatever that may be, and we wait for it to complete, and then we can clean up the buffer. What we do for that is we're going to call vk queue submit, and we're going to submit it to the queue that we passed in. For the submit count, it's 1. For the psubmits, we're just passing in a submit info that we're going to fill out in a second. And for the fence, we're just going to pass in vk null handle, because we're not doing anything with fences. And then we need to make sure that we wait until it's complete, so we do vk queue wait idle. And once again, we pass in the queue just so it knows which queue it's waiting for. So let's get that submit info filled out real quick. It's going to be a vk submit info. For the S type, we want to make that equal to vk structure type submit info. Then we have a command count, command buffer count rather, and that's going to be 1. And then we have p command buffers, and that's just going to be a reference. Confused myself. That's going to be a reference to command buffer. Alright, so that should take care of all of that. And the last thing we need to do is free up space. So we just do vk free command buffers. And once again, logical device, the command pool, the command buffer count, which is 1, and the command buffer. So that should handle everything we need for the copying function. Now it's time to actually put that to use. I'm going to jump back over to the Vertex buffer, and here's our create function. So we created the staging buffer, we created the Vertex buffer, and then we need to call a copy right underneath that. So we're just going to drop down below. We're going to call copy buffer, and we can pass in everything we need. So we should pass in the logical device, actually we may not have a reference to the command pool. Yeah, we're gonna have to pass that in. That's okay. We'll get that in a second. So ultimately we're gonna pass in the command pool, then the staging buffer, which is the source, the vertex buffer, which is the destination, the buffer size, and the transfer queue. So that's going to be the queue that's getting passed in. And again, we don't have a reference to that either. So let's go ahead and add those to our create real quick. So in create vertex buffer, we're going to go ahead and add a vk command pool pointer, which is going to be the transfer command pool. And we're also going to add a vk queue, which is the transfer queue. And these should both be pointers, and they should both be constant. Getting a little sloppy as we go along, sorry about that. And I spelled that wrong. Okay, so let's grab these, and we're going to copy those into the header. And now we're going to want to drop this down onto another line because it's getting really messy. Same here. And here, we'll just copy these and paste them in here. Command pool, transfer queue. So that should do all the copying properly now. And while we're at it, you know what? I did something similar over here with when I was making the new classes. Let's make it so that creating a new vertex buffer just calls create. It's so much easier. So we're just going to drop that here, grab all this, paste it here, paste it in the header, and then we just need to go through here and remove all the types. It'll cut down on the number of lines we have in our engine code. There we go. That looks better. Alright, now one last thing we need to do. We have the copy buffer call right here, and the staging buffer is meant to be temporary, so we actually need to clean it up when this function is done being called. So we're just going to go ahead and do a vk destroy buffer, and we just pass in logical device, staging buffer, and a null pointer for the p allocator. Once again, this needs to be dereferenced. And then we also want to free the memory, so we call vk free memory, and then logical device, staging buffer memory, and another null pointer. So that should handle everything we need. Now let's hop back over to plan. Oh, actually, looks like we still have an error somewhere here. Ah, totally missed that. For cleanup, since we moved everything back, since we moved the references to the buffer and the buffer memory out of PV buffer, calling cleanup, you would need to pass in references to those as well. So we're just going to go ahead and take care of that. Where's create buffer? Here, we'll just jump over here. So, where'd it go? Create buffer. You pass in a reference to the buffer and the buffer memory. Does cleanup already have that? Oh, it does. Yeah, never mind. So then all we need to do is actually pass these in here. We just pass in vertex buffer memory. And that should clean up correctly now. Alright, so let's hop back over to the CPP. Now that we changed how the vertex buffer is created, we can just take these right here and just put them into the constructor. And that'll save us a line. And I think it's missing some of the arguments. What was it again? Let's take a look. So, logical device, physical device, surface, transfer command pool, and transfer queue. So for the transfer command pool, we just pass in a reference to transfer command pool. And for the transfer queue, we pass in a reference to Oh, actually, you know what? I never made a transfer queue. That's my fault. So remember before when we switched to the PV command pool, graphics, and transfer command pool? We also should have made new queues for everything. So we had display queue. I'm going to rename that graphics queue. And we also need a transfer queue. Because we're submitting these separately now. And now we should be getting some errors here. Good, there they are. Alright, so first off, I'm just going to put transfer queue here because we're going to need it. But now, if we go down to everything else here, it doesn't still seem quite happy with that. You know what it is? Transfer command pool, I need to actually call get command pool. There we go. That seemed to do the trick. Great. Alright, now we're going to go down to these errors. Now, if you'll notice, we have this vk get device queue, and it's still referencing the old display queue. So what we want to do is we want to take this, copy it, replace this one with graphics queue, replace this one with transfer queue, and then this should be indices transfer family. So now we have those two. They haven't been declared properly within the create logical device function, though. So let's go ahead and, because they all need their own create info and that sort of thing. So we call fineqfamilies, that gets done. And then what we want to do is, right underneath that, we're going to do a create info for every single one of the families. So we're going to do an std vector, and this is going to be of vk device q create info type. We'll call it, q create infos. And then we're going to make a set of the unique q families. Oh, I need to include set. Alright, so now we're just going to go ahead and make this a set of ints. Call it unique q families. And it's going to equal indices graphics family and indices transfer family. We're also going to need to give it a queue priority, which is going to get passed in down here. So I'm just going to take that, copy it, cut it, paste it up here, because that's going to get passed into everything in the loop. And now we're going to make a for loop for int q family in unique q families. So it's going to iterate through all of the q families that we have, which is only the 2, but still. And then we're going to grab everything here, paste it into that for loop. So what it's going to do, it's going to make create info. It has a proper s type. Null pointer is still correct for p next. The flags are still correct. Q family index should be q family. So it's just going to pass in whatever index we're on going through. The queue count should be 1. Queue priorities are still correct. And then at the end of it all, we want to do queue create infos dot pushback. And we're going to push back this create info. So now we're going to have a vector of all the proper create infos. Alright, so if we come down here, when we get to p create infos, we're going to just pass in, instead of reference to the q create info, we're going to pass in q create infos dot data. And I believe that should do everything we need now. Yeah, I think that does the trick. So that should, oh, actually we still have an error down here. So if vkq submit, and we want to change this to the graphics queue. Graphics queue. There we go. And same here. And then, so is everything good with that Vertex buffer? I think get command pool needs those parentheses. And I believe that's everything. Let's try running this one more time and see if we actually get the output that we want. Alright, and everything looks pretty good. If we're looking through the log here, everything seems to be created successfully. All the buffers, memories allocated, the duplicate, or the 2 command pools. I think we're doing fine. So everything looks exactly the same as it did in the last video, but now everything is using much more optimized memory, and we've also managed to refactor a lot of things so that everything's a little bit more separate. So hopefully that takes care of everything we need. If we run into any more errors down the line, I can always go back and fix them. So that's all for this video. Thanks for watching. Sorry it ran so long. I keep trying to make them shorter and they keep getting longer. But in the next video, I'm going to, again, try and make it a little shorter, but we're going to try and implement an index buffer for everything. So as always, thanks for watching, and if you'd like to know when I come out with a new video, just go ahead and subscribe.